But let's move on to another part of this. The database that we had when AS400 first came out had initially, okay, the concept that everybody was going to use their data in relational ways. And so SQL was the interface that everyone was going to use. But because we came from the integration of System 36 and System 38, and they both had data models that were not that already, we had to have our database be able to handle things that were the data model of the System 36 and the data model of System 38. That was absolutely crucial to the success of us moving into AS400, right? We were able to move folks from those two environments, keep them up and running. But the other thing that it did was it provided people an opportunity to continue using those old data models and to not take advantage of that SQL interface. So back in the day, we had this query engine that had to know that most of the stuff that was coming into it as a query was coming in as a query that was from the System 36 or the System 38 data model. And yes, it might be coming in via SQL, but most of it wasn't. So we had a very simple classic query engine that when it was asked a question in the form of query would have to deal with the fact that it could be coming in several different modes. And so it couldn't be very complicated as it tried to produce its answer. Now, over the years, DB2 architects who had decided from the beginning that the AS400 should have a purely relational database driven by SQL queries, they wanted to create a query engine that could take advantage of knowing that it was dealing with SQL and SQL only. It was not dealing with those old data models. If it could do that, it would be able to learn from the past and use what it learned from one query, from one application, to improve queries from other applications. But to do that, you had to know that it was coming through SQL and being implemented by this underlying architecture of DB2 interacting with our single level store. Okay, so we created this thing, the new query engine that was optimized for the idea that it was going to be coming in with standard SQL, and it could do a whole lot more if it knew that. Okay. And it would give you that DB2 answer much more quickly, and it would improve queries for other people because of what it learned about how the data was stored and how it was being queried. The thing is, we still had lots and lots of stuff, especially back in the 90s, that was in these old data models. And so over time, while we still had the query engine, the new query engine that was being implemented in the late 90s, early 2000s, most of the queries were being handled by the original query engine. And then over time, more and more of the queries, even the queries that came from the old data models, we found ways to send that through the new query engine so we could learn a bit more. There actually is still a need for that older query engine for some things. It actually works better. So it's still there, but by and large, the database had to evolve over time. So yes, it's still part of the architecture, but finally, the query engine that was envisioned by the people who did the AS400 came into existence and got optimized for the kinds of things that are going on in the data world today by the time we became IBM I. Because you see, back then, what everybody used it for was purely transactional data, purely relational transactional data, even if people didn't use it relationally. These days, however, people want to do things like analytics. Analytics was never conceived of when this whole architecture was created in the first place, but it was getting more and more important to business users. And some databases out there in the world decided to re-implement themselves using, instead of a row-based, transaction-based way of doing things, column-based. So you would organize your database, for example, based on the state you're in. That's a column. Okay. So things would be organized closer together in the database if they were all in the same state. I'm just using an example here. Okay. But that slows down traditional workloads. And of course, most of the workloads that do most business still have to have traditional workloads as their basis, right? Transactions are the key to business. So the IBM I answer was to enhance the way we did our row level transactional focus thing was something called an encoded vector index concept that sat over the top of that, which would allow us to do analytics or columnar-based things without incurring the penalty of having to reorganize and restructure the database. And that has allowed lots of applications to take advantage of it to not only do the things that they do super well transactionally, but also do things super well when they're doing analytics. This is just one example of a particular workload that is significantly better when you get to combine the row-based relational IBM DB2 with the capabilities that we have for the encoded vector index. And again, that did not exist as a part of the architecture in the days of the AS400 or even the I series. This concept was added to the databases architecture when we got to be IBM I, and it has been a tremendous value to a lot of our